Hey guys, this is a part one of so many parts videos that we need to talk about how you can write the equation or the formula for an arithmetic sequence or a linear function. And then what that might represent in terms of these other options that are here off of your Mathia work. So I just want to choose one workspace and dive into it. The main part of this video, depending on how much time I feel that this video is worth watching, is that it's going to be focusing on the rate of change. Since we're talking about an arithmetic sequence, different from maybe some previous content that you've been working on. In an arithmetic sequence, the terms 1, 2, 3, 4, 5, those aren't actually terms, those are just positions. The -7 is the first term. The -7.5 is the second term. -8, -8.5, -9, etc. The terms are continuing. Can you identify what the growth rate is? That's the wrong word. Can you identify what the rate of change is from one point to the next? If you don't know how to do that, I would say follow these rules. We always want to focus on the second term of the sequence. We want to focus on the -7.5 as the initial place to begin this calculation. Don't start with the first term. Start with the next one. How do you go from term 1 to term 2? Well, the way we can mathematically determine how much that is to take the second term and subtract it by the first term. So I'm using a negative for the phrase I literally said subtract, but the first term is actually also a negative number. So I'm going to put that in parentheses just to kind of like visualize that I don't want to lose a negative. Bad science happens. Bad things in science happen, or in money, or in life, if we lose track of this negative symbol. One of my favorite games playing with my children is that it's a game called Exploding Kittens. Not a sponsor, not an endorsement, but the point is that in that game, as you're playing the card game with other people, you might have a card that causes some sort of damage to happen to them. They have to draw 2 cards and therefore lose the game. There's some sort of like reason for that to happen. If they play a nope card on top of your action, that takes the action away. But it gets fun when someone else adds a nope to the nope. And so 2 nope cards actually turn that action back around and you have to do it. So in other words, a nope nope is a yep. Sorry if that's outside of your lexicon. But the point being that taking those 2 negatives, they cancel each other out and end up with a positive. A nope nope is a yep. So in this problem, -7.5, yes, it is subtract -7, but it's the same as plus -7.5 plus 7 because of the way the 2 negatives work together. And when you actually do this, you calculate it out, you wind up with a -0.5 as a calculation. Check to see that it works. We shouldn't just one shot say that we're done. We can probably rely on it for the majority of these calculations. You do have a certain number of circles you have to fill up in this Mathia workspace. But for the first time out, just check to see that it works. Also because we're probably running into the issue with negative negatives, how do you make sure you manage those? So -8 subtracted. We always go a subtraction. We take the second term and subtract it by the first. Or we take the term right before. That's what's going to go here. Larger, smaller, or next and the previous. Now, again, reminder, we have a negative negative, and a negative negative is a nope, nope, cancels out. Nope, nope is a yep. So in this problem, -8 plus 7.5 tells us that we wind up once again with -0.5. We're going to cap that as part 1 of this video because in part 2, we're going to use this number to help us write the explicit formula. Thanks for watching.